So in this video, we're going to look a little bit more at having to do trig more than once. So we started to see that at the end of lesson 5. So we're going to see some other examples that are real world applications of trig and why we might have to do it more than once as we kind of go through. So if I'm looking at exercise number 1 here, we have a movie is projected onto a large outdoor screen. The bottom of a 60-foot tall screen is 12 feet off the ground, and the projector sits on the ground at a horizontal distance of 75 feet from the screen. Determine and state to the nearest tenth of a degree the measure of theta, the projection angle. So notice the projection angle here is kind of given. It's not in itself in a right triangle. And we know we need trig to be a right triangle for us to make this work right now. So because this doesn't necessarily fit so nicely, instead what I want us to look at is the right triangles that are present. So first we have the right triangle that is the whole picture here, and we could find this whole angle. And then we have another right triangle that we can highlight in here, and we can find that piece. And then if I take the big part minus that small angle, we'll be able to solve for our projection angle theta. So again here, I'm going to sketch myself 2 right triangles. I'm going to call the angle I'm looking for right now x, so that's the whole thing. We know the horizontal distance is 75, and the whole height here is 72. I added those together. And then when I'm looking here in this right triangle, I have the opposite and the adjacent, so we know we're using tangent. Now remember, when you're looking for a missing angle, we hit the inverse button on our calculator. So the only time you hit that is when you're looking for angles, and that would be our setup. I'm going to set up our other triangle before going to the calculator here. This time my height's going to be 12, and we'll have 75 as that horizontal distance. So we could do tangent of y is equal to 12 over 75. Same thing when we're looking for y here, we're going to do the inverse of tangent, because when you're looking for the angle, we would plug that in. And so now I'm going to let the calculator do the work for me. So I got my 2 angle measures, and we're taking the big angle minus the small angle here, and we get 34.7 degrees when we round that to the nearest tenth. So take a moment and let's write that in. Okay, so when we fill that in, we just showed our subtraction and our 34.7 degrees. Now in the second problem here, we're given the map of a campground, and we have the different parts labeled, like the campsite, the first aid station, the supply station, and the tower. We know that the first aid station, the supply station are 400 feet from each other, and we're given different angles that are formed. Now, what we're trying to find is the distance between the campsite to the tower. So at first it seems pretty good, because that's part of the big right triangle here. And we could find x, but the problem is we have 400 feet, but it's not the full length of one of the big sides of the triangle. So unfortunately, we can't do anything with that triangle just yet. What we could notice, though, is that if we look at the other right triangle that's present, we can take that 400 feet and set that up. So I might want to use this side here, because using this side, it will give me one of the sides of the big triangle to help lead to that orange part. So if I'm looking at the blue, I have the opposite and the adjacent, so we're going to do tangent again. Tangent of 72 equals y. over 400. And we're going to cross multiply here. So we get 400 times tangent of 72. And we're going to plug that right into the calculator. And we end up with 1,231.037415. Now, I'd be careful rounding because we're not done with this number yet. We're going to need it for the second part. So I would leave a couple decimal places. Like we have 6 here, and I would let the calculator do the work for me in that case as well. So just keep that in mind for now. 0.073415. I originally wrote 37, so just switch those for me. But so now that's that side here, and we can use that for the next piece, because now from 55 degrees for the orange triangle, we have the opposite. We want the hypotenuse, so we're going to be working with sine. So now we have sine of 55 is equal to the opposite, which is that whole big thing again. So remember, I'm not rounding just yet, just to be safe. When I cross multiply, we'll end up with that number divided by sine of 55. So I already have that stored in my calculator, so I'm just going to go here, and I'm going to divide by sine of 55, and we get 1,502.863. We want to round to the nearest foot, so 1,503 feet. So you notice we had to do 2 different setups to get to our final answer there. It's the only way we can do it. Okay. As I look at this third problem, now we have a homeowner's building 3 steps leading to a deck modeled in the diagram below. All 3 step rises, H, A, F, G, and D, E are congruent. So I'm going to mark them. And the step runs, H, G, F, E, and D, C are also congruent. Each step rise is perpendicular to the step it joins, so you can see the right angles are shown there. Angle CAB is 36 degrees, and angle CBA is 90 degrees. Now, it also mentions that each step run is parallel to AB and has a length of 10 inches. So the runs are here. So each of them are 10. And we know that all 3 are parallel to this piece here. So I'm going to take one of these right triangles here just to find the individual step rise. I'm looking for X here, but notice that Z shape that's formed. Think back to what we know about parallel lines. Parallel lines form congruent alternate interior angles, so I can have the angle 36 here and here. So when I look at my right triangle now, I have a 10 here. I'm trying to find X. We have 36 inside. So popular one today, tangent. Okay, so when we cross multiply, we're looking at 10 tangent of 36. We plug that into the calculator. And when I round to the nearest tenth, we're looking at 7.3 inches. Okay, last one for this lesson. Now, this exercise 4 was a part 4 question of a Regents exam. There's a lot of parts to it, and there's some tricks along the way. So it's a 6-point question. There's definitely things you have to look out for. So we're really going to break this one down here. So we have Frida, who is training to use a radar system and detects an airplane flying at a constant speed and is heading in a straight line to pass directly over her location. She sees the airplane at an angle of elevation of 15 degrees and notes that it's maintaining a constant altitude of 6,250 feet. 1 minute later, she sees the airplane at an angle of elevation of 52 degrees. How far has the airplane traveled to the nearest foot? So there's no picture for us here, meaning we have to make our own, or you don't have to, but I would strongly recommend trying to make a picture here. So I'm going to draw in that first picture. So we have 15 degrees is our angle of elevation, and we were also told that it had a constant altitude. Remember, altitude's another word for height, of 6,250 feet. Now here's where we have to be careful. When the next one has an angle of elevation of 52 degrees, you have to think, is it getting closer or further away from Frida? Well, think about how 52 is getting bigger. That's like tilting your head back a little further. That's actually going to be getting closer to her. So that's going to look something along the lines of this. Because notice, I'd have the same altitude, that's 6,250, but now this angle would be 52. Now, it's kind of hard to work with that picture itself, so I would definitely draw the two pictures not overlapping so you can have it set up. I'm actually going to do it over on the side here. So the thing we're looking for in this case is how far we've traveled. So we want this amount. So basically what I'm going to do is find the bottom pieces. So when I set this one up, we're looking at tangent yet again. So we cross multiply. And we'll do the same thing for the red one. We're looking for y. This time tangent of 52. When we cross multiply, we end up with 6,250 over tangent of 52. So I'm going to plug both of those things right into the calculator. We can use our alpha y equals if we'd like. 6,250 over tangent of 15. And alpha y equals again 6,250 over tangent of 52. And we take the big one, subtract the smaller one so we can find the distance. You don't want to do small minus big, because if you end up with a negative number, we know we can't have a negative distance. So always big minus small here. And then we end up with 18,442 feet. Part of this that we have to look out for. So nearest mile per hour is what we're trying to figure out the speed. But first off, we're in feet. So you have to know, well, you don't have to know this actually, but 5,280 feet equals 1 mile. That's on our reference sheet. So in this case, I would put the 18,442 feet here so that these cancel. And now I'll cross multiply quick. We end up with this 3.4928 miles, which doesn't seem right. Like, we shouldn't be traveling that slow. But remember, this was 1 minute later, and now we're in hours. So we multiply this by 60. 60 minutes in 1 hour, which gets us a total of 210 miles per hour.